Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. You know, the last build that I just finished, the Arbor Press, did use exactly the same legs and almost exactly the same tray configuration as the next model in line. And most of you had guessed one or the other because you probably looked at the website and figured out which ones use these legs. Well, that would be the pedestal grinder, and this is the raw casting for the pedestal grinder. Another nice clean little piece. It's going to take minimal effort to clean that up. But the kit comes with a bunch of raw material. Comes with these little, they feel like Kratex wheels. They're not actually stone that I can tell. But boy, they sure look like stone, and I am very pleased with this. Is going to look pretty cool. This little guy will ultimately sit right on top of this base with a little bit of machine work involved, of course. And we can put a shaft through the center and mount these wheels and the pulleys and such. One of the people that commented on the last video had commented about the use of the form tool that created that beaded feature in the middle of these legs. Now, you saw me grind it by hand on the corner of the grinding wheel, but yes, you can absolutely cut high-speed steel with a carbide end mill. So I tried that for this time around. I put the tool bit back in the machine, used a 1/8 end mill, and just scalloped the end of the tool. And you can see the result is just an absolutely beautiful radius. So, more than one way to skin a cat, that's for sure, especially in the machining world. Same brass washers on either end, and the same spacers underneath here. These are a little closer on center, because the mechanism that goes on top is a little thinner. So, had to be, right? First thing I'm going to do is I'm going to make the tool post for this little grinder, and the tool post is going to come out of this material right here. This is 1/8 by 3/8, so that's about what, 3 by 9.5, 3 by 10 millimeters. And we got to turn a long diameter on that. That's about 1.5 millimeters in diameter, and then cut the thing off so that there is about 1 millimeter or so worth of flat. So we're going to make a T here with a round protrusion sticking out of it. A couple ways to do that. You could back bore this on the milling machine, saw it off, and then you'd have to figure out how to hold it to clean the end off. But I'm going to make a little aluminum nest, and I'm going to do the whole thing in the lathe, just because that's the way I want to attack it. One of many ways, I'm sure. So let's make a couple of little aluminum spacers, put this in a collet, get it done.
If you've been a subscriber to this channel for a while, you've probably seen me use these split blocks before. And the advantage of these blocks is it allows you to take a piece of round stock and cut it below center. If you were holding this in a vise, and it was a short piece, you could hold it end to end, of course. But on a long piece, when you get below center, naturally you lose your grip or you hit your jaws or whatever, but the geometry changes. So pinching it out on the ends like this, you're going to waste a little bit more material. But it allows you to do things that you couldn't normally do. I'm establishing the center line of this piece of material, and I'm going to trim the top here in a second just to make sure that the part is laying flat, which it is. Just imagine taking the rectangular piece of material and just embedding it into this 1/2 inch diameter. And that's how you come up with your numbers. Everything is worked from center. So I'm going to put the end mill and I'm going to cut this thing down to below center to a dimension half the thickness of the piece that I want to squeeze in there. Now that's going to make sense in a second. I'm going back and forth with the cutter like that because I'm ramping down into it. I'm not going to plunge cut it. Each one of these passes back and forth. The table is coming up. It's a good way to do steel as well if you have to mill a long channel. Don't overload the cutter, just ramp into it. Very helpful technique. I'll cut this slot to the width of the material. It's pretty ugly right now, but don't let that scare you. Not yet. And that's how you establish how deep it is. You just know what you're going to end up with and measure it right over the radius on the outside of the material. Be very careful when you establish the end mill back into the slot. If you don't have a hard, positive, rigid stop on your quill, a little bit of extra tension on that handle and you could blow your dimension by a couple thousandths. So take extra caution when you do that. Finish the width of the channel. It's going to take a couple passes. You're going to see me test fit the material going in there. And the more accurate you make this little boat here, the more accurate your part will come out in the long run. So take your time with it. Go back and forth as many times as you have to, and make it as tight as it needs to be. That's a 5/16 cutter. It's 312. I guess that's about 8 millimeters, 9 millimeters. Hang on, I'll tell you what it is. Just a little smaller than an 8 millimeter diameter cutter right there. And with the assistance of the digital readout, I'll walk it back and forth on the y-axis to establish my width for the brass that I want to hold. Real time here was about 15 minutes to make this entire nest. Time well spent once you see the application. Now make sure that when you raise up not quite half the thickness of the material that's going to be nested in there. This part is 125 thick. I just came up 60 thousandths. So if your material was 4 millimeters thick, come up just less than 2 millimeters. You're going to want a parting line. Take it over to the buffer, take all the uglies off of it, and there was plenty of them. Little Scotch-Brite takes the minimal burrs off the inside of the channel. And there you go. Now over to the bandsaw. I made a mistake on this one. I should have started at the end where my left hand is, work back into the material instead of having to deal with a small piece like this. You don't want to do that. So start on the outside and work towards the large stock. Always have some big piece to grip a hold of. And just clean it up, make both pieces the same. For orientation purposes, I usually put a larger chamfer on one side of the blanks than the other. That way I know how it goes together next time I use it. If you are off center or there is a discrepancy at all, you want to minimize your potential for future error. And you can see the nice rectangular hole in the center of that material that's going to hold that stock, and it's going to hold it quite well. Put this in your bag of tricks, put it in your model tooling, label it, and away we go. When I get closer to the finished diameter that I'm looking for, you're going to see me take a partial cut and back the tool out. That's a cleanup cut at a different feed rate. Double check it. I know I have to take a couple more thousandths off of this. So watch the partial cut. Just a little bit, back out, do it again, and now finish. That'll give you a truer diameter with less deflection because the diameter connected to the main body of that part is bigger than the end. So you'll see me do that a lot on parts that are long and extended, or else you'll see me do it all in one shot. Either technique works quite well. As you have heard me preach in the past, make sure that you know the relationship between your primary facing tool and your parting tool. Makes it a lot easier to control the thickness of the part or the thickness of the feature that you're trying to achieve. You just add whatever value that is to the dimension you're looking for, set your machine, and just off you go. Works really well.
Next pieces in line are actually 4 small dog bones made out of this material right here. This is 1/8 square brass. And I guess that's about 3 millimeters across the flats. Now, since I don't have a 1/8 square collet yet, I decided I'm just going to make a split bushing to hold that. Now here's a trick. If you measure across the points on a square stock and you don't have a drill that'll make it the same size, reamer, bore, whatever, you can simply break the edges on that material ever so slightly and it'll fit the hole without much effort. When you stick it in the collet or when you stick it in the little bushing, make sure that one of the edges does not fall into the split. However you do that split, I did mine with a slitting saw, and relieve the back side to the wall thickness of your choice, but make sure it is thin enough that the little collar flexes. This is how I'm going to do these parts. These parts are no big deal until they get to the mill for the cross holes. Then I think you're going to like the way I'm going to hold these in the mill. Bulletproof. You're going to like it. Stick around. Next part in line is nearly identical to the one you just watched, except there's no boss on the end. This is a little dog bone, almost identical to the first one, but no boss or threads yet. The very next task in hand here is to pop some through holes through these guys. Basically where the red dots are. Now the center to center on all these hole patterns is the same, although the holes are different sizes. This is 125 material, it's 1/8 of an inch across, and when you start putting through holes in small material, the problem is the parallel underneath. So I'm just going to suggest that if you have a scrap piece of aluminum laying around, use that as a parallel. Next problem is, chances are the parallels are thicker than the part and you can't close the vise. Well, that is really not a problem if you make the little attachment I am about to show you. It's going to work like a charm and should be pretty quick. Let's do it. Setup for this operation is relatively simple. I have a jaw stop on my stationary jaw. And for reasons you'll see here in a second, I'm placing a parallel across the gap in the bottom because you don't want anything locating in there. And here comes my fixture. This is a great little fixture. Love this fixture. Has a 271 thick rib up against the stop. Now you have two options. You can either use your edge finder against this face or this back face and just add the distance in the back of the jaw or the stationary jaw. You locate that as such. Now the little pieces that go in here sit right on top of the aluminum. Spacer plate. When you close the main vise, the spacer plate acts as the new vise, and it will come closed and squash that little part all day long, provided this overhang right here engages the movable jaw first. I have a little spring pocket that I put in there so I can squash this completely flat. And there's no reason you have to work small if the parts are small. That just makes it more frustrating. There you go. Doesn't get any easier than that. Drill straight through the part into the aluminum. As you start to consume this nest, deck it off, put more spacers underneath. You can use this for a very long time. This one has seen a few modifications over the years and should perform well. Let me pick up the centers and I'll come back and we'll show you how fast it will be to drill all these holes. Now I didn't show the tapping of the small side because it just wasn't worth showing. And yeah, for those of you with really good eyes, these end holes are just slightly off center. Not quite sure what happened, but I visually picked up on it. I thought it was the chamfer on the part was inconsistent, but it actually is not. Re-establish the center for the large end. No idea. Shop gremlin got me on that one. Still going to be a functional part. It's going to bother me, but I'm just going to leave it as is. Take it back over to the lathe, part these off the length, and put the sub-assembly together for you. A quick look at all the pieces involved in this little sub-assembly. These are 172 screws. They are about 72 in diameter. That's about 1.75 millimeters-ish. Saw me make these guys before, and you just saw me make these just now. Got a little mock-up block. I'm going to put this together, make sure everything lines up, fits, and is nice and straight. Let's take a look.
Small ain't the word. Jeez. I need better eyes. That is surprisingly rigid.
Okay, after a couple of hours worth of effort, a little bit of setup time, this is the reward. It is only a mock-up on the block right here. I just wanted to make sure everything fit, looked good, Man, I didn't have to make it again. I have no intention of making this again. I would if I really needed to, but not going to happen. You can see how small it is. It is extremely small. But as usual, I think it's going to look great on this kit. This is not a very hard kit. And you should treat yourself to one. This is going to look great sitting on the desk. Thank you very much for watching this episode. Do appreciate it. Come on back for the grinder body and some of the wheels. I might have to wait a day or two. I don't have the equipment to do it. 172 internal and external left-hand threads. The external I could probably get away with, but the internal I'm going to have to wait for a tap. So there you go. For now, Joe Pye here at Advanced Innovations in Austin, Texas. I'm out.